Okay, now we are moving to the topic called matrix transformation, and as you can see, it's in geometry and measures. What is the competency here? The learner understands and uses matrices to transform shapes on a coordinate. There are many learning outcomes. There are over 8. There are over 7 learning outcomes. So you can see that it's hard to set an activity that is going to exhaust all the 8 learning outcomes, but you can try at least and you set one that covers at least 3 quarters of the learning outcomes. That means that you need to give more than one AOI to cover or to exhaust all. So this one says, the school, by the way, before we proceed, you can go and to the playlist and visit the transformation playlist. There are many examples in there. You can learn from the videos. Okay, this one says, the school design team is working on a new triangle logo graphically with the coordinates A. So we have coordinates A. Our A is 3, 1, B 5, 1, and C. The coordinate of C is 5, 3. With area, they are having its area as 2 square units, square centimeters. Okay, centimeters squared. Okay, but they are represented with a process of finding the matrix of transformation and the area of the final image. Find the need to reflect it, the triangle across the line y equals x. So the first line of reflection is y equals x, or is the matrix of transformation there is 0, 1, 1, 0. And also enlarge it with the scale factor 2. So when the scale factor is 2, is it 2? You know that our matrix is always equal to k 0, 0, k. So substituting in the k, now this is the matrix that they are looking for. This is the first matrix, this is the second matrix they are looking for, which is 2, 0, 0, 2. If you want to see all this in the details, please visit the playlist. You will see how all these things are coming about. Whilst the line of reflection y equals to the matrix of transformation is 0, 1, 1, 0, everything is in there. Okay, so now they want us also to first get, let us first get the coordinates. So we know that the matrix of transformation times the object will be equal to the image. So I have the first one 0, 1, 1, 0 times my object. Now my object, these are acting as the objects. What will I get? This will be now the image. This times this, then this times this. So I'm going to get this times this 0 times this, that is 1, 0 plus 1, 1, 0 plus 1, I mean plus 3, 3. 1 plus 0, 3, 5, also 5. So this now the A, B, C, and this will be the A prime, B prime, C prime. Now I come to the second matrix, M2. I also need to get the object, I mean the image. So M2 times O equals still the image. Now this one is acting as the object. So my M2, which is 2, 0, 0, 2, times now 1, 3, 3, 5. This will give me, now this times this 2, 2, this times this 6 plus 0, 6, 0 plus 6, 6, 0 plus 10, then 0 plus still 10. So this is now, this, remember this was A prime, B prime, C prime. This is A double prime, B double prime, matrix multiplication. So now you can write the coordinates of the images. So A1, A prime 1 is 1, 3, B prime 1 is 1, 5, C prime 1 is 3, 5. A double prime is 2, 6, B double prime is 2 comma 10 and C double prime is 6 comma 10. After that, they went on to tell us that after this transformation, they want to determine a matrix that will return the transformation matrix to its original position. I mean, that will return the final image to its original position. What we do, now we get the last matrix of transformation times the first matrix of transformation, so that we get the single. We first get that the one that takes it direct from the original position to the final image. So we get 2, 0, 0, 2 times now 0, 1, 1, 0. What do we get here? This will give us now, this time this is 0, this time this is also 0. Have 0, this times this 2, this times this is 0, 2. So this time this is 0 plus this time this, which is 2, this time this is 0, then plus this time this, which is also 0. Now this is the matrix that will transform A, to transform now A to A double prime. But we need it that is going, we need that matrix that is going to bring it back to the original sorry, that brings it to the original position. So meaning we get the determinant of now this. So the determinant of M2, M1 will be, then we get the product in the minor, I mean the major diagonal, minus the product in the minor diagonal. So this times this, then minus this times this, which will give us -4. Then we get the adjoint of M2, M1. We said interchange, then we change the signs of elements in the major. So now we get now the inverse of this matrix. We said that 1 over the determinant times the adjoint, 1, -2, -2, 0. When multiply in there, a quarter times this will get 0. A quarter times 2, the negative and negative will give you a half. Then this and this will also give you a half. And this and the 0 will also give you a 0 there. So now this is the matrix that is going to take this back to this coordinate there. So that's where we are now. But now they asked us also to get the area of the final image. The area of this image. What we do, this matrix, this matrix takes us to the final image. What we do, that in area of the image will be according to magnitude of the determinant of the matrix M2, M1 times the area of the object. All these ones, if you want to see all of them in details, please just go to the playlist, then touch where we have transformation. You'll see everything. They are there. Now, the determinant of this matrix, we get its magnitude. So magnitude of -4, then times the area. Remember, our area was just 2, as you can see there. So meaning this will be now 4 times 2, which will give us 8 centimeters squared. So the final image had the area of 8 centimeters squared. So that's how we come to that. We want to determine the matrix that return the area of the transformed triangle. So that's it, members. But don't forget, if you want, you have to reply. Come and say, now the coordinates of the image, the first image, coordinates of the second image, the matrix that will transform. Now the matrix here, the matrix that takes A, B, see, back to ABC is this matrix here, 0, a half, 0. You reply. Then also we can say the area of the final image is this. You reply everything in details. So if you want to see them in details, different transformations, because here we just talked about enlargement and then reflection, but they are many rotation and so on. Just find them in the playlist and then see. That's it. See you.